Imagine a startup founder who insists on being the CEO, the lead engineer, and the HR rep all at once.
Right. Yeah, that never ends well.
Exactly. I mean, it works when you have maybe 5 employees, but when you scale up to like 500, that founder just becomes this massive bottleneck.
Oh, yeah, totally. You just can't function.
Right. So today we're looking at how that exact same bloat happens in AI development. Welcome to the deep dive, by the way. Our mission today is to, well, pull some practical insights from Christopher Coleman's notes on a system called Warden.
Yeah, it's a fascinating look at how Warden started as this sort of clunky experimental app and evolved into a massive operational platform.
Right, and it's a perfect case study for you if you're building scalable AI systems. Like, early on, Warden was basically a Swiss Army knife. It tried to do absolutely everything.
Yeah, it tried to ingest data, reason about it, and execute controls all at the exact same time. I mean, it was doing way too much.
Just like that overextended founder.
Exactly. So Coleman realized the only way to scale was, well, amputation.
Amputation? Wait, really?
Yeah, they had to physically separate the intelligence, like the core AI brains, from the connective tissue of the system.
So that's where they introduced this unified gateway, right? I saw they built it in Go.
Right, exactly. I mean, Go is super fast, so it's perfect for handling heavy network traffic. They put this gateway right in front of the central AI.
But wait, I have to push back here for a second. Putting a gateway right in the middle? I mean, doesn't that just create unnecessary, middle management in your code?
Yeah, I hear that a lot.
Doesn't it just add latency?
You'd think so, but it actually prevents chaos. The gateway acts as this universal translator.
Oh, I get it. So instead of a dozen different mobile apps and security scanners trying to talk directly to the AI,
they only talk to the gateway. Exactly. It normalizes all those messy requests into one standard format. Because, once your AI system becomes distributed, your interface boundaries literally become your governance model.
Right. You simply can't control what you haven't cleanly separated.
Exactly.
But because that gateway is catching literally all these requests, it suddenly becomes this massive fire hose of data.
Oh, yeah, a total flood.
So how did Coleman keep that flood from just completely drowning the core AI?
By strictly separating observability from intelligence.
Meaning they split the sensor data from the decision-making.
Yes, exactly. They built a dedicated backend just to handle the telemetry, the raw sensor data.
Right, using tools like Prometheus to scrape CPU usage and Grafana for those visual dashboards.
Yeah, and that keeps all that noise completely away from the AI's reasoning engine. Because, a CPU spike on a Grafana dashboard, well, it's just evidence.
It's not a judgment.
Exactly. A mature system has to preserve the distinct boundaries between what happened, what the system believes happened, and what should happen next.
Let me jump in with an analogy here because it's like the difference between a smoke alarm and calling the fire department.
Oh, yeah, like that.
Right? The telemetry, the sensor data is just the smoke alarm. It just screams, hey, there's smoke.
Yeah, but if you merge that sensor layer into the decision intelligence layer, well, then the alarm automatically dials 911 every single time you burn toast.
Which creates incredibly brittle automation.
Exactly. Which is why they overhauled tools like Warden Scan. It used to render a verdict on its own. Now it's just a pure sensor.
So it just produces security observations and hands that evidence off.
Right. It hands it off to be correlated with historical behavior before the central intelligence makes any judgment at all.
Okay, so if all this data is cleanly separated from the AI's decision-making, how are human operators supposed to interact with it?
Well, Coleman's notes are really clear that the desktop and Android apps shouldn't contain the intelligence. They exist purely to expose it.
But doesn't that basically reduce the user interface to just a dumb terminal?
Not really. It redefines the UI as a highly specialized lens. I mean, if every mobile app tries to run its own mini AI, you end up with devices disagreeing on the system status.
Oh, right. So you need a single source of truth.
Exactly. The UI's job is to present historical context and clear decision matrices to the human.
Because for the human operator, nuance is everything. A simple red or green status light just doesn't cut it.
Right. You need to know the difference between a server being truly offline versus being reachable but unauthorized.
Which require radically different operational responses.
Exactly. The UI exists to empower the human to be the final gatekeeper over a transparent trail of evidence.
So for developers listening to this deep dive, the big takeaway for building scalable AI isn't about shoving more reasoning into the center.
No, not at all.
It's about defining strict interfaces outside the model, tracking where your data comes from, and explicitly coding failure semantics.
Yeah, that architecture is what turns a collection of brittle AI scripts into a truly resilient enterprise platform.
Which brings us right back to that startup founder who finally has to delegate. But as enterprise AI shifts toward these decentralized ecosystems, where no single application holds the complete, unquestionable truth, how will we audit these systems when something goes wrong? That is the million-dollar question right there. When a massive distributed system makes a catastrophic error, who or what component takes the stand? Think about that next time you're deciding where to put your code's intelligence.